Alright, so I think I'm recording. Let's take a look at these problems. They're asking us to determine the end behavior of the graph of rational functions. So rational functions are a ratio of polynomial functions. And we're always going to start out with these problems comparing the degree of the numerator against the degree of the denominator. So we do not want our numerator denominator to be in factored form, or if it is, recognize that it is in determining the degree. So when it's just terms here, we look for the variable with the largest exponent, and I can see that the degree of the numerator here is 1. I can see that the degree of my denominator is 2. So the end behavior is a horizontal asymptote. In any time that it's bottom heavy, the degree of the denominator is larger than the degree of the numerator, then the horizontal asymptote is the x-axis. It's the line y equals 0. Because if you think about it, if you haven't gone up or down, the line y equals 0 is more commonly referred to as the x-axis. So there's my answer, and it wants me to verify that using a graph. So I've keyed these in on Desmos already before I started the video. So let's jump in and look. Ooh, I forgot to. Hey, which graph is ours? All right, so let's double check that I've keyed that in correctly. X minus 10 is in the numerator, yes, and 4x squared minus 100 is in the denominator. So I've keyed that in correctly, and so let's cut and paste the graph onto here so that we can look at that end behavior. So I'm going to shrink this up because you've already seen it. And let's come in and let's zoom out a little bit. The end behavior of this graph is what's going on for values that are far away from the origin. So here's our origin. Far away from the origin, we're interested in what's going on with the graph when we're out here. Can't see that, can you? Or I can't. Out here, far away on the left, as x is heading to negative infinity, far away here on the right, well, you can see that the graph is getting closer and closer to the x-axis, which is exactly what we claimed. And if we go back to the graph, if right there somebody might argue, well, it looks like it's touching it. Well, if we zoom in enough, we can see that it's just getting closer and closer. It's almost touching it. When you zoom out, it looks like the red line is on the x-axis, but really it's not. The graph, we just haven't zoomed in close enough to see it in detail when it's like this. So there's our answer for number 1, that the end behavior is a horizontal asymptote, and it's the line y equals 0. You must give the asymptote in the form of an equation. If it's horizontal, it'll be y equals. If it's vertical, it'll be x equals. Hope that helps, and I'll talk to you later.